Hello everyone, welcome to Watch Jalla Code, and today we'll be doing our day 4 of the Go series, learning Go from scratch. So, okay, today we have two topics on our agenda, which are conditionals and arrays. Yes, under conditionals, we will be treating if-else statements and switch statements. Then under switch statements, we'll see something called the anytype because we'll do what is called type switching. I skimmed through the Go by example pages of these two. Then if we have time left, we'll definitely look into arrays. So the video time as usual will be 35 minutes, and we don't have much of an intro here, so we're just going to jump right to it. So yeah, leave a like and subscribe to the channel if you're new here. It also help us grow. If you're not new, still leave a like and subscribe if you haven't, because I don't think you have. Okay, so I've started a counter, and let's just jump right into what we have for today. If you recall, yesterday we looked at variables, in the 3 of Go, we looked at variables and looping. We learned how to use the var keyword. We learned that basically variables are containers that hold values of any type, like the primitive types we learned in day 2. So we also learned how to do multi-variable declaration using the var keyword. We learned the type inference that Go does, meaning we don't have to use the types that we use here. They're not really necessary because Go will just infer the type. We also learned how to use the shorthand for variable declaration. We learned what zero values are, and zero values are the stuff that primitive types have if you don't initialize their variables to anything. Like here, the character is a container that holds a primitive type, which is string, but we didn't point it to anything, so it holds the empty string, which looks like this. The empty string is just a string with nothing in it. So that's the zero value of strings. Yeah, we also looked at constants. Constants are basically variables, but unlike variables declared with var, constants can't be changed. Yeah, so that's just the key difference. Also, you can't use the variable shorthand with constants. Then we looked at loops. We learned that Go only has a single looping construct, which is the for loop. And this bit of code, if I were to uncomment it, all it says is while I is less than 3, print I, then increment I by 1, go back to the top and do it until I is no longer less than or equal to 3. So when I becomes 4, we stop doing this. We also learned some other ways of looping, and if you've forgotten, I recommend either going through the Go by example website or looking at the videos, because we're not going to look through all that again. Okay, so let's define our main package. Let's import. Let's define our main function. And let's go to the Go by example website. A lot of goes in that statement. All right. So yeah, we are looking at if else on the Go by example website. Everyone should definitely check out the Go by example website. It's just gobyexample.com. Currently, we're on the if else portion of it. So yeah, so branching with if and else in Go is straightforward. Then they give us a basic example. If 7 modulus 2 is 0, print that 7 is even, else print that 7 is odd. Okay, you see that one thing you really notice is that our if statements here, there's also an else statement. So basically, if you're familiar with English at all, you know that if something is not true, you can, or if something fails, you can try another thing. So this basically says, if this fails, try this. Or if this fails, just print this, because we're not trying it. We know this will work because it's just like a definite else statement. So if 7 modulus 2 is equal to 0, print 7 is even. Else, if 7 modulus 2 is not equal to 0, just print 7 is odd. We know that if and else are not like conjoined twins or anything. You can have an if statement without an else statement, but you can't have an else statement without an if statement. It says right here, you can have an if statement without an else. If you are familiar with any form of programming, this should not come really as any surprise. So if 8 modulo 4 is equal to 0, we just print 8 is divisible by 4. There's no else branch. So if, for example, 8 modulo 4 happened to not be equal to 0, we would just end up doing nothing in this entire code block. we see here that we can use logical operators like and or in conditions or conditional statements. Like here, if 8 modulo 2 is equal to 0 or 7 modulo 2 is equal to 0, then we do what's in the code block. And you can clearly see that we have two statements here. We have two conditional statements, not one. But we don't need the two to be correct to print what's in the code block. That's why we use the or. Remember, I believe we looked at the or logical operator in our first video. Basically, it only needs one thing to be true. Either this is true, either 8 modulo 2 equals to 0 is true, or 7 modulo 2 equals to 0 is true for what's in this code block to be printed. And a statement can precede conditionals. Okay, so in Go, it looks like a statement can precede conditionals. This isn't too strange. It's like with the for loop, how we did for num shorthand I, num less than something, then we do what's in the loop. It's a similar concept. But here we are saying if the number is, okay, no, first we are instantiating a variable that is equal to 9. If that variable is less than 0, we print the variable is negative. Else, if the number is greater than 0, we print it has 1 digit. Sorry, if it's less than 10, we print it has 1 digit. Else, if it's not less than 10 and if it's not less than 0, we say it has multiple digits. See, this is like a 3-point branch, and if statements only end up at one branch. You won't have if statements that touch more than one branch. So in this branch of 3, only one code block actually matters. That's the one that will be printed. So I guess we can all know. So here we know that the number variable is set to 9. So if number is less than 0, number is negative. Is 9 less than 0? It's not. So number is not negative. Therefore, the first code block is ignored. Then see here we have an else if statement. In Python, this is written as elif. In JavaScript, it's written as else if as well. So it's just like saying else, then if. Then you write another if block. Else if number is less than 10, print number has 1 digit, which is true. So after we print this, once you are in a conditional branch, once you print something to the console, you just stop the branch, you leave the branch, because you already have the matching condition. So you won't keep going, meaning we don't even look at this last branch. So we can copy this code and like go to the VS Code scene and try it out. Or rather than doing that, let's write our own statements. Let's write something like if, okay, let's define a variable. So if boy is equal to, sorry, then we print, format.println, then we just print boy to the console. So we can try this, try to see what this prints. We do go run. Okay, no, let's change to the hello directory, because that's the directory we're currently in. So go run. Yeah, because this is clearly a very simple concept. If the value of the boy variable is equal to this string, we print what is here, which is true. So we print what is here. We can do something like else if the value of the boy variable is equal to Jake, we print something else, fmt. Then we can add a final else branch that would be triggered if all else fails. So we can look at else branches as if all fails. Basically, if all fails, do this. That's what else branches can be looked at. If nothing else can be triggered, we just straight up use the else, because we go through every branch. But I previously said that conditionals don't look at every branch when they find a branch that is true. Here, the code that we have here, let's copy it and place it right here. And in this code, once we confirm that Jalla is indeed boy, we print this and we don't look at anything else. We can basically say nothing else matters once you find this. But if we had it that peradventure this was perhaps James, we would check this first condition, we'll see it doesn't match, then we wouldn't execute what's in the code block. We will go to the next condition, see that it doesn't match, then we wouldn't execute what's in the code block, then we'll just execute what is in the else block, because the else block just executes regardless. No, it executes when all else fails. The else block executes when all else fails. If you ever get to an else block, you are most likely you are going to execute the else block because it means every other condition failed. We're going to look at switch statements soon, and you see that the final else block is usually like the default statement of switch. Yeah. Then we can look at how you can do something like this. If boy or if person, then we can use the shorthand way of declaring, then add an actual condition. Okay, no, let's use a number, person 9. If person greater than 9, greater than or equal to 9, then we execute what is in this code block, which can be. So here we initialized the person variable, and then we check if person is greater than or equal to 9. If the person is greater than or equal to 9, then we actually print the brackets. Yeah, that's basically how we use this type of statements in this context. So there's not much to if statements, but we can try an example using the logical operators. If 5 greater than 4, then we do or 4 less than 8, or 4 greater than 8 can so we just need one condition here to pass. The condition that will pass, of course, is 5 is greater than 4, because 4 is not greater than 8. So the OR operator just needs a single condition to pass for it to execute what's in the code block. And another thing I would like to say is that what we're basically doing, what conditionals actually take is like, if they take a Boolean value, if bool prints something. I'm just going to comment this out. So conditionals actually take booleans. This will evaluate to a boolean value of true. It's only when what is in what the conditionals argument evaluates to true that we print or we do whatever is in the code block. So conditionals take boolean values, and if the boolean values match with what the conditioner is expecting, here the conditional is expecting a true value. If it matches, then they execute what's in the code block. So that's the meat of conditionals. Any other thing can really be just practiced in one's leisure. Once you know like what they do, everything can be practiced at your leisure time. So then I'd say we just go to the next thing, which is switch statements. Let's look at switch statements. Okay, because we've looked at every major thing. Now switch statements. Switch statements express conditionals across many branches. So once again, switch statements are basically conditionals as well, but they work differently from if statements to the best of my understanding. So here's a basic switch statement. So here they instantiate a variable I to be 2. Then they write I as, so now we are switching the cases of I. So we know that I is 2, right? So we switch I with each case. The first case is that I is 1, which is incorrect, so we don't do this. The second case is that I is 2. So immediately we find a matching case, we execute what is under it, what is in its code block, and the code block here is just print line 2. So we can say that the switch function matches the cases, it matches its argument with the cases we provide. That's what we can say the switch function does, or the switch statement does. It matches its argument with the values we provide with each case. Case 1, format.println 1. So does I match the first case? No, it doesn't. So we don't do this. But I matches the second case. So we do this, and we don't have to check case 3 because I has already matched a case. Okay, so then here you can use commas to separate multiple expressions in the same statements. Okay, and they said we use the optional default case in this example as well. You know, the default case in switch statements are like the else block. if all else fails, we run the default. Here, there is no default statement. So if the case of 2 was not included, we wouldn't print, nothing will be printed to the console for this section of the code. Here we are switching something from the time module because we imported time here. We are switching the weekday. So if today is Saturday or Sunday, this command can be seen as the or, is equivalent to the or we used in the print statements that we had previously. So if today is Saturday or today is Sunday, we can print it's the weekend. But if all that fails, meaning if there's no case that matches the switch's argument, we default to printing it's a weekday. So that's fairly simple. Switch without an expression is an alternate way to express if-else logic here. So switch case and switch statements are they're basically conditionals like if-else statements. Here we also show how the case expressions can be non-constants. So here, time, okay, the time, they get the time, the current time, the time now, then they switch the time. Oh, something, okay, no, I didn't mean to do that. So they switched, but they didn't pass any arguments. They said the case, we also show that the case expressions can be non-constant. Rather, they just put like an expression, what we would put in the if-else statements, rather than passing something to actually switch. They just made this work like basically an if-else statement, like saying if the current hour is less than 12, print this, else print this. Okay, so we understand that. And here, a type switch compares types instead of values. Here, I think this is called a type switch. I said initially that we would learn about interfaces, so I'll pause on this because I also don't know what an interface is. So we would just Google the interfaces of Go. So let's copy this code and go back to our VS Code scene. Okay. If we can interact with the code. So what we do here is we instantiate variable. Here we instantiate a variable. We print to the console. Then we switch, or we can say we match the value of I with the cases. I prefer saying match because for one, it's more intuitive if you say match. And two, there's something called the match statement in Rust that works exactly like switch cases, but kind of better. So here we are matching, let's say we are matching the value of I with all the cases available. Does it match the first case? We know that I is 2, so we definitely know I doesn't match the first case. So we print, so we don't execute what's in the code block. Does it match the second case? Yes, we know that I matches the second case. So we print what's in this code block and leave the switch statement entirely. We don't check case 3 because we found a case that matches with what we are switching. So it matches with I, so we just go with this. We never actually touch this statement. When we can print this to the console to see that it just shows us print writes 2 as 2 is what it will print. So go run. Yes, write 2 as 2, because it doesn't have to check 3 because it has found its matching case. So that's all there is to switch. You are just matching the switch's argument with all the cases available. And if you include the default, for example, if we included defaults and we don't have to pass an argument to defaults, we can just say, we can say unknown. And let's say we remove this bit. You would see that nothing now, as we've commented out the case that match, it will just print the default unknown because it's to go through every case and see that no case matches. So then it prints the default case, which is unknown. So we can go run to test that out. Yeah, write 2 as unknown because now the matching case has been commented out, so there's nothing that actually matches. So now we put that back in and look at this. So here we see that we are using a new package called the time package. So we can read the synopsis. So package time provides functionality for measuring and displaying time. The calendar calculations always assume a Gregorian calendar with no leap seconds. Okay. time.now gets the current time. Okay. All right, we could look at the documentation another time, but we know right now they are calling the now method of time and they are matching it with, then they are calling the now method, then they are getting the weekday and they are matching it with the current case. So what we are matching is the current day of the week. We're matching the current day of the week. If it's a weekend, we do this. If it's not a weekend, then we execute the default statement. So this is basically a conditional. Yeah, it's basically conditional. So we are switching the weekday with Saturday and Sunday, or Saturday or Sunday. We can say Saturday or Sunday because it only has to be one of these days for it to actually trigger what's in this code block. Today is a Tuesday, so if we run this, it will tell us it's a weekday, which it does say right here. It is a weekday. So very basic, very simple. Now this is, I would say this is more fun because now, if you notice, our switch statement doesn't actually have an argument. So we're using it like how we would use a conditional. We're checking if the current hour is less than 12. If it's less than 12, we say it's before noon. Else, the default, if this fails, we go with the default, saying it's afternoon or afternoon. So yeah, that's basically all there is to this. There's no argument here. So we can basically call this an if statement. Case t.hour less than 12. Right now it would print it's afternoon because it's currently 2 p.m. So format.print line would be, it would match with the default case because the case we have here would fail. So we can say that the first if statement fails, then it has to go with the else block, which is the only thing that's available. So this is the print it's afternoon, which it does successfully print. Then the last one that has the interface thing, because we have like 9 minutes left, I'd say we ask, okay, let's check the documentation. Let's check the documentation, the code documentation. Okay. Interfaces means you can put values of any type, including your own custom types. All types in Go satisfy an empty interface. Interface is okay. So this is basically, we know that it's an empty interface. Okay, let's see what the Stack Overflow thing says. Okay, we've got like 8 minutes. Maybe we won't have time for arrays, but we'll see. So this, okay, no, we don't understand what they're writing because we've not gotten to this point. At least I haven't gotten to this point. No. This is not what we want. Can we try reading it too? No, we can't. We can't. Okay, so let's go. We do know that interfaces means you can put values of any type, including your own custom type. All types in Go satisfy an empty interface. Okay. Okay, look at the docs. Fantastic. We'll spend like 2 minutes on this thing. Back to, okay, in general programming, interfaces are contracts that have a set of functions to be implemented to fulfill that contract. Go is no different. Go has great support for interfaces and they are implemented in an implicit way. They allow polymorphism in Go. This is big programming English. In this part, we will talk about interfaces, what they are and how they can be used. So what is an interface? An interface is an abstract concept which enables polymorphism in Go. A variable of that interface can hold a value that implements that type. Okay, type assertion is used to get the underlying concrete values, as we'll see in this post. Okay. The zero value of an interface is nil. That means it holds no value and type. Okay, I think because the zero value of an interface is nil, it's why it previously said that you can put a value of any type because interfaces hold no type. So they are basically like, I would say containers, typeless containers that can hold any type. So when you say something is of the interface type, you mean something is of a type that can hold anything. Basically, it's a malleable container that can kind of hold whatever you want it to hold. So I guess that makes sense. Yeah. A is of the interface type, meaning A can be, you can point A to anything. And yeah, an empty interface holds an any type. That's why it's extremely useful in many cases. Below is the declaration of an empty interface. So that means in this point, what we do here is we are declaring an empty interface as the arguments to this function. So right here, when we call the function, we pass in we can pass in any type of arguments, booleans, integers, or strings, because the argument holds a type of any. It can hold any type. Then we switch based on the type. Okay, this is called a type switch. A type switch, okay? So a type switch compares types instead of values. You can use this to discover the type of an interface value. In this example, the variable t will have the type corresponding to its clause. The variable t will have the type corresponding to its clause. So it gets the type of t and matches it. So this is called a type matching. So for this is obviously of the Boolean type, this is of the integer type, and this is of the string type. So interfaces help us define dynamic variables that can hold any type. I guess we can add this to our list of primitive types, even though it's technically not a primitive. It can help us hold anything though, so it's good to know. So let's go to the VS Code scene to see what we are looking at. Okay, so we know that I is a variable that holds anything, and we check the type of I. The type of a variable is like our primitive types. Basically, is it a string? Is it a Boolean? Is it an int? So we switch the type. Okay, we switch the type. If it's a Boolean, we print I'm a Boolean. If it's an integer, we print I am an integer. And if we don't know the type, we print don't know type t. This is called this is formatting. I believe we'll learn this tomorrow or on our next video, day 5 of Go. We'll learn print formattings. But basically, I think this is I don't know what this is called. I learned this in C a long time ago, but I've forgotten because I don't use it. So I guess we'll learn this tomorrow, or we can look at it now, but we have like 3 minutes. I want to use that to round up the video. I want the videos to stick to that time limit. So if we did, this is what we would call, what am I is what we would call a function, because we passed it a function that prints stuff. We'll also learn about functions probably tomorrow or in our next video, which may be tomorrow. So we switch the type that we get passed in the function as the arguments. We switch the type with Boolean, int, or the default. So if it's not a Boolean, if it's not an integer, we print we don't know what type this is. So for the string, we say we don't know the type string. So if we tried for the float type, we did what's I, and we passed a float 2.0. Remember the floats are decimal values, and we did go run because it's not of the Boolean type and it's not of the integer type. We will print don't know type, don't know type float 64, or don't know type floats. So we know that this is a 64-bit float, but our function what am I does not know this. Okay. So there we have it, guys. Unfortunately we couldn't cover arrays, and yeah, we couldn't cover arrays, which is really unfortunate, but I guess we'll have to do that in day 5. So we can see go day 4, conditionals. Yeah, so just a quick recap. We covered if else statements and switch statements. We also saw how to use the any type, and if we wanted to define a variable of the any type, we would do something like this. var any, and give it to the interface type, meaning we could put a string in any. Now then console, then fmt.println, then we could print any that holds the string. So go run, yeah, print string. So this is how you define variables of any type. This is how you define variables of any type using the interface. Well, okay, so that's it for today. I hope you liked the video. If you did, then please do give a like, subscribe, and Yeah, follow for more because we'll continue this journey. Okay. Also, I'm thinking about doing a video on how to make a Telegram bot using JavaScript. If you are interested, by JavaScript, I mean Node.js. Yeah. So if you're interested, please, you can leave a comment below. Yeah. So have a nice day and I'll see you in our next video. Thanks for your time.